Hi guys, today I've taken up a Fourier series problem, and the function is x sine x, and as you can see x sine x has been defined over the entire time axis, and it's an even function. Now to establish the Fourier series, what we'll do is first we'll calculate the full range Fourier series, then we'll calculate the half range Fourier series. Now by full range Fourier series we mean that we'll take a certain section from 0 to pi, or possibly 0 to 2 pi, in whichever manner it is required. Now we have chosen 0 to pi, which means the section of the curve from 0 to pi shall be repeated along the entire time axis as shown here. So as you can see, the resultant waveform doesn't have any symmetry. So we'll have all the terms, a naught, cosine terms and sine terms. Now for the full range Fourier series, what we'll do is we'll repeat the part of the curve from minus pi to pi. You can also do for minus 2 pi to plus 2 pi. In that case the angular frequency will change. So it depends upon your requirement, which part of the curve you want to repeat. I have chosen from minus pi to pi. Once you repeat the part of the curve from minus pi to pi, the waveform looks like as shown here. And let us start from the full range, right? As you can see, this is the full range Fourier series, and the functional form is DC term plus cosine terms plus sine terms, and here we first calculate the DC term. DC term is 1 by time period average of the function over the entire period. The period is from 0 to pi, and we get value is equal to 1, which means a naught is equal to 2. Now what is the angular frequency? Angular frequency that we need to consider here is 2 pi by t, time period is pi, so it will be 2 radians per second. So to calculate the cosine term coefficients, the format shall be 2 by t, t is again pi, 0 to t whole period, and omega naught is 2. So once you integrate it, you get this expression. Fine. Similarly, you can calculate the sine terms. Sine terms is 2 by t again, 0 to pi, and t sine t is the function, and integrate over the entire period. This was for first harmonic, and you get this value minus 0.5659. Similarly, for n equal to 1, 2, 3, 4, 5, you can calculate the cosine terms using this expression. And interestingly, it is matching with the values obtained from the software, right? Once it matches with the software calculations, you can be sure that your procedure was correct. See, these are the values calculated through software, and they were well within limits, so you can be sure that your procedure is correct, and the terms that you have, the general term that you have established is okay. Now let us calculate the half range Fourier series. For the half range Fourier series, the average term remains same as before. In other words, a naught is same as before, which is equal to 2, but now omega naught will change because the time period is 2 pi, and it becomes 1 radian per second. Now we will have only the cosine terms because the function is a even function, and sine terms will vanish. So you need not calculate the sine terms because it will be 0, and the cosine terms will be calculated like this: 2 by t. T is the time period, t sin t is the function, n is equal to the harmonic number, omega naught is 1 radian per second here, and you integrate the whole over the full period. Full period is from minus pi to pi, and because of the symmetry you can use this relation to 4 by t from minus pi to 0, half period. And once you calculate this, the general term becomes cos 1 plus n pi by 1 plus n, cos 1 minus n pi divided by 1 minus n. This is the general term from n equal to 2, 3, 4, 5 up to infinity. For n equal to 1, you cannot use this expression because the denominator becomes infinity. You have to separately integrate for n equal to 1, and it becomes equal to 0.5 minus 0.5. Once you calculate the various coefficients, you'll find you can compare with the software results, and you'll see that this is the software result for the half range Fourier series, and they are matching. So once they match, the problem is solved, and you can be sure that your general term was okay, general term was precise. Now actually this was the question which was I went through, and unfortunately none of the options are correct. None of the options were correct because they were not matching with the software calculations. Only the first harmonic cosine term and the second harmonic cosine term were matching. The remaining terms were not matching. Like for the third harmonic, the coefficient is like 2 by 15, which is not equal to 0.25. So you need to be careful. Sometimes the options themselves are wrong, and you have to trust your calculations. And hope you have enjoyed the video. Thanks for watching.